Can you sit? Can you sit? There's Teddy. Teddy came to say hello. Say hi to the kids. We're going to talk about silver and copper. What do you think? Yeah, good boy. All right, go have your nap. Thank you. No, I don't have a treat for you. I'm sorry. I just wanted you to come say hello. Now he's going to bug me the whole time. I should never have done that. Okay, so our lab today, copper wire in a solution of silver nitrate. So, beginning question, what amount of copper is needed to completely react with a blank gram, so many grams of silver nitrate? Okay, we'll be giving you a certain amount of silver nitrate, and you guys will have to do some stoichiometry to figure out how much copper you're going to need, and then you'll get some copper, and we'll then perform the experiment. Okay, our background information. Teddy's still sitting here wanting a treat. Now, I don't have my usual slate, so this may be kind of entertaining to watch. The slate from school is at school. The first thing it asks you to do is write a balanced equation. We're going to take solid copper and we're going to add it to a solution of silver nitrate. And this is actually something you did in the oxidation reduction labs, the single replacement labs we did a few weeks ago. You actually put a piece of copper into silver nitrate. The copper will replace the silver and consequently form copper 2 nitrate, and the silver will be deposited on the copper wire. Okay? Next thing is to balance it. I have 1 copper, 1 copper, 1 silver, 1 silver, 1 nitrate, 2 nitrates. So I need 2 of these and 2 of these. What that means, for every 1 copper atom that gets dissolved into the water and replaces the silver, we're going to produce 2 silver atoms. Okay? Every 1 copper is going to need 2 silver atoms because it's going to need both those nitrates. All right, the next question on there, what type of reaction is this? And that is a single replacement. Then it asks us for oxidized and reduced. Review. Oxidized, OIL, oxidized is losing. So we need to go through and figure out the charges. Copper, by himself, element, going to be a 0. Silver, always, always, always a +1. Nitrogen is a part of nitrate. Remember that these all have to add up to 0. We know oxygen is a -2. -2 times 3 is -6. We've got 1 silver. So now I have 1 plus what? -6 equals 0. +5. On the other side, copper is now a +2 charge. We know that because the nitrate's a -1 overall, and there are 2 of them. Plus, nitrate is not going to change the nitrogen or the oxygen charges. And silver is a 0. So, the question is, who has lost electrons? Losing electrons means you're going to have more protons than electrons. So you will be positively, or you will be moving in a positive direction. Your charge will be going up. So, copper went from a 0 to a +2. Silver went from a +1 to a 0. Which one was oxidized? If you said silver, you were wrong. Copper is oxidized. Now, let's remember how we do this. Copper with a 0 will become copper with a +2 charge. How many electrons did it lose? It lost 2. If copper is what's being oxidized, guess what's being reduced? If you said silver, this time you are correct. Silver is going to do what? It's going from a +1 to a 0. So it's going to gain 1 electron to become silver solid. Now, we have to balance. Fact of life. 2 electrons up here, we need 2 down here. So we're going to multiply all of these by 2. And that works out with our balanced equation up here. So copper is being oxidized and silver is being reduced. It's a lot, isn't it? All right, the next question asks, what does percent yield mean? Percent yield, well, yield is what you get. Percent yield is, well, the best way to think about it is when you make cookies and the recipe says you're going to make 48 cookies, but we all know that you eat some of the dough. So if the recipe says you're supposed to get 48 cookies, that's theoretical. But you actually get 30 cookies, your percent yield is the actual amount, or the measured amount, or the experimental amount, divided by the theoretical yield. If I do this with a calculator, 30 divided by 48 is 62.5%. So percent yield for my cookie recipe would be 62.5%. So definition of percent yield is the ratio, the amount, the actual amount compared to the theoretical times 100. And it tells you basically how well you have done in your experiment. Okay, next question. You're given 1/2 gram of copper. What amount of silver would you expect to get? Uh-oh, now we've got to do some stoichiometry. I know, it's my favorite. So I need my equation again. We know that 1 copper plus 2 silver nitrate yields 1 copper nitrate and 2 silver atoms. Right? The question, and of course I've already forgotten. Everybody say hi to Mr. Bush.
Hi,
Stop
guys.
walking, Mr. Bush, so they can say hi to you.
Hi guys.
Joe and Lori are not here, so I can't show them off. Oh, well, I can show you their picture if you want to see that. I'll show you that at the end. Okay. What were we doing? We had 1/2 gram of copper. So, if we think about our mole bridge, did I put him on here? Nope. Our mole bridge, the first thing we need to do, we have 0.5 grams of copper, and the first thing we have to do is change copper to moles to go up onto our bridge. Change copper grams to moles, we divide by the molar mass of copper, which is, I'll show you something really cool that I just figured out. What is the molar mass of copper?
The atomic mass of copper is about 63.546 atomic mass units.
Thank you. Pretty cool, huh? I want one of those Alexas or Google Homes so that I can do that in the classroom, but I can also use my phone. 63.546. I'm going to go round to 63.55. How many moles is that, folks? Well, get the handy dandy calculator out. I wonder if Google can do that calculation. Okay, so we have, and I'm going to go ahead and write it up here, 0.00787 moles, even though you don't need to write it down if you're doing it in a 0.00787 moles. What is the next step with our mole map? Well, the next step is the ratio. What is the ratio of our known, which is copper? I wrote that in the wrong spot. Copper, and we're trying to figure out how much silver we're going to make. What's our ratio? Well, our known is copper. So copper goes on the bottom. We have 1 mole of copper that gets used for every 2 moles of silver that is produced. Now we've done our conversion. Next we have to change it back to silver. Being the total geek I am, what is the molecular mass of silver? Oh, that didn't work because it picked up when I said I am. Google, what is the molecular mass of silver?
The atomic mass of silver is about 107.8682 atomic mass units.
Did you hear that? The atomic mass. What did I ask for? The molecular mass. She kind of owned me there, didn't she? Okay. So 0.5 divided by 63.55 grams times 2 times 107.87 equals 0.00. Holy cow, that's not very much. 0.006677. So we'll go 00. Technically, we'd only need 1 significant digit because I only used 1 there. We'll do that. Not very much silver made. All right. Next one. Last one. You want to get 2.5 grams of silver produced. How much copper and how much silver nitrate would you need? All right, more stoichiometry. Already forgotten what it said. 2.5. Excuse me. All right. We want to get 2.55 grams of silver produced. So that's our starting point, our known. 2.55 grams divided by the molar mass of silver, which we handy dandy happen to have up here. The ratio of silver to copper is 2 to 1. And the molar mass of copper we happen to have up there, 63.55. Divided by 107.87 divided by 2 times 63.55. 0.736 grams of copper. Right? Now we're going to do the same thing, but we're going to calculate silver nitrate. 2.55 grams of silver, 107.87 grams in 1 mole. This time we're going to do our ratio of silver to silver nitrate. 2 moles of silver need 2 moles of silver nitrate. Now we have to, and I'm going to do it again. What is the molecular mass for silver nitrate?
Silver nitrate has a molar mass of 169.87 grams per mole.
That is so cool. I'm sorry. I'm geeking out. All right. 2.5. 5 divided by 107.87 times 2 divided by 2 would be 1 times 169.87. So we would need to start with 4 grams, 4.15, so 0.4015, so we'll go 4.02. Ta-da! Now you've done your background information. I know you're excited. All right, so now we're going to start our procedure. Step 1 is safety. You gotta wear your goggles. Okay? And do not touch, if you can help it, the silver nitrate. Okay? It will leave little black spots. One time when I was cleaning up the lab at South, I wiped my hand across my forehead and I had little black spots all over my forehead for the rest of the day, for the rest of the week. It was not pretty. All right, step 2. You're going to get a piece of copper wire and you are going to use steel wool. I can't spell. Steel wool to scrape across the top of it, and basically you're going to be removing anything that's oxidized on the outside. Step 3, you're going to get a 50 milliliter beaker. You're going to put your name on it and your hour using a vis-a-vis. And then you're going to find the mass of Mr. 50 milliliter beaker. Step 4, you're going to find the mass of your copper wire, record it, and the mass of a small vial that has silver nitrate pre-measured in it. Make sure the lid's on there. Okay? All this stuff needs to be recorded. Step 5. For step 5, you're going to add the silver nitrate from the little vial, and you're going to put it into your carefully measured 50 milliliter beaker. Then you'll weigh the empty vial with its lid. And record that. Step 6, we're going to add water. We need 30 milliliters of water exactly, which means we need a graduated cylinder. So use some water from your wash bottle. Fill the graduated cylinder to the 30 milliliter mark and pour that into your beaker. It's labeled and has silver nitrate in it already. Step 7, you're going to take the wire you have and wrap it around your finger so you get a coil. And if that's kind of looking head down on it, it'll actually kind of look like this. All right. For 8 and 9, you're going to take that coil and a piece of a stir stick for coffee, a wood splint, and you're going to hook over the end of it, and then you're going to lower that down into your silver nitrate solution in your 50 milliliter beaker so that eventually it'll look like this. And you've got some of that wire underwater. And you will wait for 30 minutes. After that 30 minutes, part 2, you're going to observe with your eyeball what's happening in the 50 milliliter beaker that has the wire and the solution in it. You'll then shake as much of the silver that has formed on the wire off. So take your little wood splint and shake it up and down. You want the silver to gather down here. You can even use your water bottle to knock off pieces. Okay. Step 3, you'll dip the wire, the part that was in the other solution, into a small beaker of acetone that I will have up at the front of the room. And just dip it in and pull it right back out, and that will help it to dry more rapidly. Step 4, you're going to need filter paper, and you fold it into quarters so you get a little cone. And that filter paper then needs to find the mass. After you've found the mass, you should have a funnel. I think the instructions actually say beaker, but you're going to put the filter paper inside of the funnel that happens to be sitting inside of a larger beaker. That was step 5. Step 6, no, that was still step 4. Step 5, you're going to pour the beaker, the 50 milliliter beaker, into the funnel. This has got silver nitrate solution, copper 2 nitrate solution in it. We're not really sure what, but it needs to get put into the funnel. And all of the silver that's inside of the beaker needs to go there too. All right, so any silver that's hanging on, you can use the wash bottle to aim upwards and knock that out. Step 6, we're going to wash our filter paper. And what that means is after it has completed draining the first time, you go ahead and fill the funnel or the line, the filter paper up. Don't go over the edge of the filter paper, but you'll add more water to the filter paper, and you'll do this 3 times. Step 7, we're going to need the piece of filter paper put onto a watch glass and bring it up to the front so we can put it in the oven. And that is what you need to do.